Alright, so let's go through now and start talking about Lambda expressions. So I've created, as you can see, a new project, so make sure you do that so you can follow along with what I'm doing. So Lambda expressions, often called lambdas, are a new feature introduced with Java 8. And what they do is they provide us with an easier way to work with interfaces that have only got one method. And a typical or often used, they are often used in places where we use anonymous classes. And you'll see what I mean as we progress through the videos in this section of the course. But let's start by reviewing how we use a runnable object to create and run a thread. And then we'll see how this relates to lambdas. So I'm going to create a new class in this file, in this main.java, that we can just kick off as a thread, or kick off as a runnable object. So class code to run implements is going to be runnable. Then we just want to implement the method, which will be the run method. And we're just going to print out a simple message in there, printing from the runnable. Okay, and then we'll go back up to the main method and we'll kick off that runnable. And the code would be new thread, new code to run, closing parentheses, dot start. So it's not anything you haven't seen a number of times before, so we run this. Okay, printing from the runnables. Now that obviously works, and that's one way of doing it. And we could obviously also use an anonymous class. So I could just comment out this, or leave it in there for now, but we could change this to put new thread. Then we could have put new runnable. And get IntelliJ to fill in the code for us, so we could have just printed out the message in there. Printing from the runnable. And here we just put our parentheses, right parentheses, dot start. And we can obviously kick it off that way using an anonymous class. And it'll obviously give us the same result. But in both cases, what we had to do was write several lines of code to accomplish what we wanted to do, when all we really cared about is the system.out.println statement. Everything else was sort of just filler code to get it to be able to be executed. So in other words, the rest of the code is there to instantiate an object and implement the single method in the runnable interface. And it would be nice if we could just pass the system.out.println statement to the thread constructor and not have to write all the extra code that isn't really doing anything. Now, using a Lambda expression, we can actually do that. And here's how we would do that. So I'll delete this again, the anonymous class method. And with a Lambda, we would type in new thread. And this time we would change it, put parentheses, dash greater than sign. And then we just type S out again, and we're printing from the runnable dot start. And I'm getting this error here because I haven't set my language level to Java 8, and you can see it says Lambda expressions are not supported at this language level. And as I mentioned at the start of this video, it's a Java 8 feature. So what we need to do is go into our module settings. We can do that by just right clicking up here, module settings, or open module settings to be more complete. And we want to make sure, after clicking project, that our project language level is set to 8. And you can see in there it says lambdas. So just click on that, click on OK. That error should disappear. And we should now be able to just right click and run that. And we get the same result. So that's a Lambda expression. Now every Lambda expression's got three parts. First one is the argument list. The second one is an arrow token. And thirdly, the body. So let's take a closer look at what we wrote here, the Lambda expression we used. And specifically what we're talking about is this code here that I've got highlighted. So this expression has an empty argument list. The arrow token is just the dash character followed by the greater than character. So we can refer to that as the arrow token. Now the body is the code that we want to run, which in this case is the system.out.println statement. Now when the compiler sees a Lambda expression, how does it know what to do? Well, it knows that one of the thread class's constructors accepts a runnable parameter. And in addition, it also knows that the runnable interface only has one method, in this case run, which doesn't take any parameters. So it's able to match the Lambda expression's argument list, with no parameters, with the run method. Now, because the compiler needs to match the Lambda expression to a method, Lambda expressions can only be used with interfaces that contain only one method that has to be implemented. So these interfaces are also referred to as functional interfaces. Now, by using a Lambda expression instead of creating a class that implements runnable or using an anonymous class, we're actually able to reduce the lines of code we have to write, and we could focus on what we care about, in this case the code we want to run. Now, before we move on, notice that IntelliJ recognizes lambdas and marks them with a lambda symbol, in the editor's gutter, this little bit over here. And if we actually click that, you can see what it did was it takes us to the method that IntelliJ believed the Lambda expression maps to. So in this case, it opened runnable.java, then it come down and had a look at the run method. And that's because, of course, with the way we've coded this, we're actually mapping to the run method. So this is a handy way what I've just done. And again, closing it down again, this little button here, by clicking on that, takes us straight there. So that's a really handy way to quickly check that the expression matches the method that we'd have to implement if we weren't using a Lambda. Now, obviously, our Lambda code is very simple at the moment. It's literally only one line of code. What if we wanted our thread to do more? So what if the run method we'd implement would contain multiple lines of code? Not a problem, we can do that as well. All we have to do is surround the Lambda's body with curly braces, just as we would do for any code block. So let's have the thread print several lines of output to the console. And just to avoid confusion, I'll just delete this extra class now that we don't need. So at the moment, we've only got it printing one class, but if we want those multiple lines to be output, or multiple statements, then what we do is just here before the system.out.println, this time we're going to put left curly brace, go to the next line. And because we've got multiple lines now, we need to finish and format the lines with a semicolon. So that's the first line. Then we can go S out, maybe make this line 2, and S out again. And let's try that. This is line %d/n3. Not sure a bit of format. System out format. So if we just run this to make sure it's going to work. So you can see now we've got all 3 lines printed to the console. And you notice that I had to type a semicolon after each statement, and we didn't have to do so when the body only had one statement. And in actual fact, you'd get a compiler error if we had the semicolon when there's only one statement. So Lambda expressions are meant to be concise. The compiler doesn't need a semicolon when there's a single statement, and in fact you can't use one when there's just a single statement. Alright, so let's add a class called employee to the main file. And the classes we'll start by having 2 fields, name and age. Let's go ahead and do that. And then we'll see how this works with a Lambda expression. So class employee. And we'll do private string name. And it's going to be private int age. Let's open and create a constructor to initialize both those fields. And let's set some getters and setters. Okay. So in the main method, let's just create some employees and add them to an array list. So what we're going to do is leave that first line there, and down here we're going to do employee John equals new employee John Doe 30, employee Tim equals new employee Tim Bachaka 21, which we all know I am, employee. Let's do another one. We'll say this one's Jack equals new employee, and will be Jack Hill 40, and do one more. Employee Snow equals new employee Snow White 22. Okay, then we'll create an array list. So list employee, and we'll call this one employees equals new array list. Then we'll just add them. Employees.add John. Employees.add Tim. Employees.add Jack. And employees.add Snow. Okay. So let's sort the employees by name in ascending order and print the results or print the result to the console. So let's look at the code first that doesn't use a Lambda expression. So we're going to do something like collections.sort. So employees, and then we're going to do a new, and we'll just press enter there to create a new comparator, which we've looked at before in the course. And the actual compare method's not going to return 0. We're going to return employee. And we'll actually, let's just change those names just so they're a bit more meaningful. Instead of O1, we'll say employee1. And O2, we'll make that name, the parameter name, employee2. So I'm going to return employee1 dot get name dot compare to employee2 dot get name. All right, so a very simple one there, and we'll close that off. And let's do a loop to do a for each to actually check the values for employee, colon, employees. Print out a message, employee.getName. So let's actually run this just to make sure that it is actually working. All right, so you can see that obviously that method is working, and we have talked about comparator before, so we don't really need to talk too much more about that now. But the collections.sort method is using that obviously to figure out how to go about sorting. And by passing this and calling this direct, it's actually sorted that array list for us. But what I do want to do is just show you the documentation because it is relevant to a Lambda expression. So I'm going to open it up, and we're just going to go there. If we go down and have a look, we'll see that it contains two methods that don't have default implementations, compare and equals. So compare and also equals, these ones here. Now we said that we can only use lambdas for interfaces that require the implementation of only one method, but the comparator documentation states near the top that the comparator implementation is a functional interface, and you probably saw this anyway as well. Functional interface, so it actually says just up here, this is a functional interface and can therefore be used as the assignment target for a Lambda expression or method reference. Let's see if you can come up with a reason for why that might be while we continue with our example. All right, so going back to our code. Now inside, if I close this run window down, so inside the collections.sort, we implemented the compare method, which uses the string.compareTo method to compare the employee names. Now the return value of compare to matches what the compare method also wants to return: a negative number when the first value is less than the second value, a positive integer when the first value is greater than the second value, and 0 when the two values are equal. And again, we've seen that in the course in previous lectures. So in this case, it's okay to return the compare to result as the result of our compare method. And you saw when I ran the application, we got the employees correctly printing out in ascending order. So now that you've seen the regular way of doing it, let's actually change the code to use a Lambda expression. Now we can use a Lambda even though there are two methods we can implement, because the equals method will always have a default implementation. Now remember that all classes descend from object, and object contains an equal method. And that means that every instance that implements comparator will already have an implementation of the equals method. Therefore, the comparator interface really only has a single method that always has to be implemented by classes that implement it. And for that reason, it's a functional interface, and we can use lambdas instead of an anonymous class. Tricky, yes, and you don't have to know or memorize this stuff. An interface's documentation will sometimes tell you if it's a functional interface, and if it doesn't, the IDE you're using might. Now we can see that the new comparator part of the sort statement is grayed out in the editor. And if we actually hover over this, you'll see that IntelliJ will pop up a message and it says that we can actually replace the anonymous class with a Lambda. So it's good to know in theory, but in practice, if you want to know if you can use a Lambda expression, check the interface's documentation, or of course you can just try it. So I'm going to finish the video here now. In the next video, we'll go ahead and update this code to use a Lambda expression. See you in the next video.